Morning to folks from India. Uh, India, again, the people from Chennai, Salem, Bangalore, and also folks from Far East, like Singapore, who had earlier participated and this time as well. They are likely to come in. Pleased to welcome you all to this Spin Chennai's video conference session with Jason Yee, the senior executive from Gremlin. Gremlin is the world's #1 platform in chaos engineering. They are some engineering executives who started very early on this area, and it is today it is the #1 platform in the world. We are navigating in a world with a lot of uncertainties and opportunities. When everything seemed to be coming back to normal during this January, February, March, after the COVID-1 wave, suddenly a giant tidal wave called COVID second wave has stuck during April. It hit us so rapidly, it was unbelievable, because some of our sessions way back in March, if you see, there was not even a scent of, about COVID striking us again. So everything is from March 28th, 29th, it started. And today it is like a tidal wave. It is only making one thing certain, that volatility, uncertainty, complexity, and ambiguity is part of our life. With digital, we are able to move on with life, majorly. So if you look at digital transformation, which is an irreversible mega trend, it is going to be a huge opportunity. So those companies which are not adapting to digital will face a lot of uncertainty and a lack of demand, and slowly relevant. So before Jason gets to talk, I have the pleasant duty of doing three things. Brief intro about Spin Chennai to Jason and to those who are new. Set the context for this session in terms of the topic. And third, not the least, introduce Jason. About Spin, a little short of 25 years as a knowledge ecosystem. It is affiliated to Carnegie Mellon's Software Engineering Institute in the US, as well as ISACA, the global body. Our vision is to build a world-class knowledge ecosystem, which is very compelling, highly relevant and value-adding to the people and the industry, distinctively futuristic and passionately co-creative. We have a 3,000-member knowledge ecosystem comprising of CXOs, senior leaders, SVPs, VPs, HR, marketing and sales professionals, quality and delivery professionals who form the core, BFSI, telecom, automotive, manufacturing industry folks, senior consultants, mentors, academia, and various other institutions. Some of the international gurus who have been associated with Spin Chennai include Dr. Watts Humphrey, who was associated for nearly 10 years, in whose honor we have instituted the Watts Humphrey Awards, which happens every year with a huge participation from the industry to bring out the best case studies from the industry on various areas like agile, high maturity processes, design thinking, and alike. We have had several international gurus apart from Dr. Watts Humphrey associated with Spin Chennai, including Louis Trigger, who is an authority in the world today on theory of constraints. He was a direct disciple of Eli Goldratt, who was the author of theory of constraints. We had Dr. Bill Curtis from US, who has contributed to the development of the world famous CMMI model, people CMM model. Manu Vora, one of the top management consultants from the US. Mark Johnson, who is again a management thought leader and a co-founder of InnoSight from US, along with Professor Clayton Christensen of Harvard Business School. Dr. Jeff Sutherland, co-founder of Scrum. Mr. Michael Krigsman, author of CXO Talk, with more than 1,000 appearances. Mr. Barry Kriggs, ex-Microsoft CTO for IT. Steve Beres, partner at Bain, focusing on Agile and systems consulting. Emmanuel Arriaga from Google, YouTube, who is a SRE at Google. We had from Twitter, Lakshmi Shankar, who is one of the top 10 executives in Twitter, share in detail about Twitter and some of the learnings of scaling up to billions of users. So many of these are available in our Spin YouTube channel for viewing. So coming to today's session, we're session ahead. Chaos engineering is a strategy for discovering vulnerabilities in a distributed system. This practice requires injecting failures and errors into software during production. So the injecting failures and errors unconsciously, we always do it in the development and quite a lot. But doing it in production in a voluntary fashion is something quite different. And many of us don't have the luxury to do, but because we being, what do you call, the customers have not demanded such kind of things from us. So that is why many of us have not been exposed to that kind of experiments. So once you intentionally cause a bug, monitor the effects to see how the system responds to stress. Stress testing per se in production is something very interesting. Chaos engineering, discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. So advances in large-scale distributed software systems are changing the game for software engineering. As an industry, we are quick to adopt practices that increase flexibility of development and velocity of deployment. An urgent question follows on the heels of these benefits. How much confidence can we have in the complex systems that we put into production? Even when all of the individual services in a distributed system are functioning properly, the interaction between those services can cause unpredictable outcomes, compounded by rare but disruptive real-world events that affect environments, make these distributed systems inherently chaotic. We need to identify weaknesses before they manifest in system-wide aberrant behaviors. So, in fact, infrastructure failures, network failures, application failures, there are so many things that can go wrong when running large-scale distributed software systems. It could potentially lead to outages and cause customer harm. Hard disk can fail, sudden surge in traffic can overload the system, a network outage, you name it. We have, whole lot of things that can happen to systems. And as systems scale, they become more complex. And in complex systems, even when all individual services and components are functioning correctly, those services and components can cause unpredictable outcomes. So successful software systems are those that are resilient against all potential failures. So today we are going to listen to Mr. Jason to see how Gremlin is advising large clients, leading world famous clients on this theory and practice of chaos engineering, and how do they make systems robust and resilient. What we are going to see. Coming to Jason, he is the director of advocacy at Gremlin, where he helps people build more resilient systems by learning from how they fail. Very, very interesting kind of work he does. Previously, he was senior technical evangelist at Datadog, a community manager for DevOps and performance at O'Reilly Media, and a software engineering at MongoDB, right? So he is experienced in unstructured data. He is associated with various technology communities such as Drupal Association, DevOps Days, Delivery Conference, and many. So he leads and grows developer relations teams to help companies connect with the target market, empower customers, and build sustainable user communities. We're really fortunate to have him share his thoughts today with us. So to the audience, please keep updating your questions. The chat facility available. At the end of his talk, we will take up the questions. in case we do not have time to get all the questions answered, Jason will respond with his answers at a later. So please keep your audio in mute, and only when called for you may unmute, just to ensure that we don't have crosstalk and noise. Chaos engineering is not just a topic of importance to Spin Chennai. It is also important to India itself as a country, as we aspire to build and scale software products, improve our success rate, and also build resilient systems. For example, the COVID has really, the second wave has caused a tremendous damage to our preparations, particularly on the infrastructure side. So I think this kind of experiments are going to really improve the way we do things, either in the public infrastructure or in private preparations infrastructure, and put us, really mature our processes and infrastructure in a big way. India has been steadily improving its ranking on the Global Innovation Index, and practices like what Jason is going to talk about are important to not only know, but to implement in practice. So we have moved to the top 50 in the Global Innovation Index from about a rank of 84. But we have a long way to go. This is 48 is not a good rank to be in. So our aspiration is to be in the top 5. So without spending any more precious time, I would like to invite Jason to enlighten us on the important experiments that he has conducted at Gremlin for various clients, as well as for the various areas in which he has worked on. I encourage at this point each and every one of you to unmute. I'll give 5 seconds for you to unmute. Then put your hands together to welcome Mr. Jason to address the Spin Chennai community.
Thank you.
Over to you, Jason.
Thanks. Greatly honored to be here. So I believe everybody can see my screen.
Yes.
Great. So I wanted, Rajaram had mentioned the value of chaos engineering, so did a fantastic job. I'm not sure how much of this I actually need to do because he gave such a fantastic introduction. But I wanted to help maybe underscore some of the value in this. I don't know if folks remember a few years ago, AWS had a major outage. The S3, which is the object store for AWS, in one of their major regions, US East 1, which is where Amazon really started. So over 25% of all infrastructure workloads are in AWS US East. US East 1 went down. Thousands of customers were affected. The incident affected actually AWS's own ability to update their own status page, which is what the joke here for Twitter is. It's an interesting day working at a cloud-based technology company. And you see the "this is fine" dog, right? Normally the dog is sitting in the room on fire and says, "this is fine." And the joke here is that for Amazon, they said, "this is fine," our service is operating normally, because the service was so broken that they could not use the service to inform customers that they went down. But because so many companies use Amazon, this impacted other organizations. So if you used Docker Hub, if you used GitHub or GitLab or Bitbucket to store your code, if you used services like Travis CI to deploy your code, if you used Slack or PagerDuty or Datadog, all of these services went down. It was pretty catastrophic. And they went down for several hours. So maybe you're thinking, well, we're thinking of moving to the cloud. You're telling me that Amazon isn't reliable. Let's try Microsoft. Microsoft, they've been around for so long. They must know what they're doing. Well, 2 years ago, actually a little bit less, Microsoft Azure went down. This affected everything from their compute to their storage to their application service and Active Directory. Active Directory is, as for those who know, is the authentication service, which means that people couldn't log in to systems. But also, if you're running Microsoft Teams, or if you're using Office 365, you're not even a technology company. Let's say you're the business manager for a bank, and you wanted to use Microsoft Word to write up a document, or use Microsoft Outlook to send an email. Well, if you were using Office 365, those are hosted on Azure. So those went down as well. So now you're thinking, well, maybe I shouldn't use Microsoft or Amazon. I know Google is the answer, right? Google, they wrote the SRE book. They know how to keep things reliable. Unfortunately, also 2 years ago, Google had a major outage. And Google's outage took out, similar to Microsoft, it took out email, it took out storage, so Google Drive, it took out YouTube, so you couldn't watch videos. It even took out Nest. So if you had one of those smart, programmable, connected thermostats, you couldn't adjust the heating in your own house because the cloud was down. So millions of users were impacted, not just technology users, not just people working on technology or technology companies, but it really affected businesses, everything from large businesses down to your small neighborhood store that was just using, Google Documents like Gmail for email. So this underscores this idea that failures are everywhere. Failures are inherent to complex systems, and the technology that we work on is complex. By its very nature, the dynamicness of our systems, of constantly having new code and deploying new applications, added with users that are constantly interacting with it in different ways, means that we have complex systems. And these complex systems will inevitably fail. And if they fail, it means that you're going to have downtime unless you decide to be proactive about it. And when we say complex systems, complexity just keeps increasing. I've already mentioned the move from on-prem to the cloud, right? You're thinking of maybe let's adopt this technology, and that's great. You should do it. You shouldn't be afraid of Amazon or Microsoft or Google, even though they sometimes go down. The shift to the cloud is good because it means that we have decreased costs. It's much cheaper for me to run a service in a cloud provider than for me to buy a server and set it up somewhere and provide internet access to it and have to manage all of that. It's also good because it allows me to scale. If my business becomes successful, I can take my small application and I can easily grow that and make that bigger. Whereas if I had it on my own systems, well, then I'd have to buy another server or buy more servers and then get a bigger facility, and it's much harder to grow. The bad thing is that this means that we have less control over that hardware and that infrastructure. And that's the trade-off. And I think it's a good one to make. But the result of all of this is that we need to build applications in a new way. Whereas before, when we could buy one giant server because we didn't know how much resources we needed, so we'd buy the biggest thing that we could and hope that it wouldn't become obsolete. With the cloud, we want to buy small services because we want to save money. And then the cloud allows us to easily add another small service and another and scale. But that means that we can no longer have giant code bases. We now want to have much smaller ones. So this has led us to build in microservices. And this increases our developer velocity. Writing small services means that we can be faster. It means that we can scale better. The downside, of course, is that this means that rather than one very large application, or maybe 10 large applications, now we're looking at hundreds or thousands of small applications. And as this gets larger and more distributed, it becomes more and more complex. And so we need a new way to test this complexity and to test for failure and to handle it. These are just a few of the examples. These are actually from 6 years ago now. This is Amazon's architecture diagram, and this is Netflix's, and you can see how many of these small services they have. And obviously, it's very difficult. The problem with the downtime, though, is that when things go down, it's going to cost us money. It's going to cost your company a lot of money. And there's the obvious costs, right? The lost revenue. If I run an online store, I can no longer sell my products. Or if I'm a business and I'm providing services and my employees don't have access to email, well, then maybe they can't work. And so I lose that value. There's also the costs after the outage. If I work for a bank, and I work with a lot of large banks, if those banks go down, they're losing money not only from not being able to do banking, but they're losing money because the government might fine them if they don't provide access to a customer's money. And then there's the unquantifiable costs, the things that you often don't think about. But when you go down, there's brand defamation. Nobody wants to use your business if you're unreliable. They'll go to your competitor. And then there's employee attrition. It's a good time to be in technology. It's relatively easy to get a job. And so if you're working at a company and their systems are always broken, why deal with the frustration? You start to get this frustration of nothing works here. Why am I working here? I could go work at another place and even make more money, but I'll have better systems and better technology. And so then you might leave, but then your colleagues who stay behind, well, now there's more of a burden on them. And so they start to realize that they're getting burnt out and that things aren't right. And so they leave. And pretty soon your team has dwindled down to a few people. So as software becomes more and more complex, not only are failures more likely to occur, but because of things like people leaving, because of things like the complexity, they become much harder to resolve and they take longer to resolve. And so this is why we talk about chaos engineering. Chaos engineering allows us to do a lot of the things that help combat the complexity and the mysteries behind it. I won't talk too much about myself because Rajaram gave me a fantastic introduction. I will say that my contact info is here on the slide. I will go ahead and post it in chat later as well. I'm on Twitter. My DMs, my messages are always open, so feel free to send me a message there. Also, you can email me, jyee@gremlin.com. I'm always happy to answer your questions. A little bit about Gremlin, though. Gremlin was the first company to offer a chaos engineering platform. And we used to think of it as just we were the chaos engineering company because our founders were two of the engineers that created the practice. They started at Amazon as on-call and incident response managers, and they then moved to Netflix and helped build the tools there. And then they decided this practice isn't just for Amazon and it's not just for Netflix. It's something that everybody should be able to do, but it wasn't easy at that time. So they wanted to make it easier. But as we've thought of this chaos engineering and as a practice, we've realized that it's more than just chaos engineering. It's about being reliable and about being proactive about improving that reliability. So chaos engineering is just one part of it. And as the company grows, we're going to start offering more and more tools to help you build reliable systems. A little bit more, there's a link here, gremlin.com/talk/spin Chennai. We have stickers. If you want more info about Gremlin, if you want to get some free stickers, we're happy to send you stickers. They look like this sheet here. They kind of look like fun tattoos in a way. But yeah, I will go ahead and quickly just type this out into the chat if I can, so everyone has that.
Yeah, if you can
go ahead.
If you can share it with us, Jason, we will share it with the entire community.
Sounds good.
Yeah.
So what is chaos engineering? We've sort of talked about that this helps you be reliable. How do we think about this? And so one of the ways to think about this, and this is something that we often say, or I used to say a lot, is that chaos engineering is thoughtful, planned experiments that are designed to reveal the weaknesses in our systems. This is short, it's memorable. We don't want weak systems, right? We want strong systems that are robust. But the longer that I've done chaos engineering, and I've done it for many years now, I've started to think that that definition wasn't accurate. So now I want to say that chaos engineering is thoughtful planned experiments, yes, designed not to reveal the weaknesses in our systems, but to improve our understanding of how systems work so that we can improve them. Now, it's been mentioned that, this COVID has really affected our world. And one of the things that I think it's done is as nobody's been able to get together and we can't go into the office, everybody started working remotely. And as everyone started to work remotely, it's become clear that you don't have to be in Silicon Valley. You don't have to be in New York. You don't have to be in London in order to build technology. You don't have to be in those locations to work for companies doing really innovative things. And that means that areas like Chennai are fantastic places to live. You can stay where you're at and still contribute. And really the only differentiator now then is how good of an engineer are you, or how good of an employee are you? And that comes down to knowledge. The more you know, the better you'll be able to build systems. So it's less about the systems itself, and chaos engineering is more about making you a better engineer, because you are the difference in technology. Technology on its own is not performant. It's not efficient. It's not necessarily good. Technology is only as good as the engineers who are building it. And so the question then is, how can you be a better engineer? How could you be a better innovator? And I think that comes down to how much knowledge can you get, right? It's not going to be about that AWS certification. It's not about any of that, because that knowledge that you get, there's no certification for the exact application that you're working on or that exact infrastructure. So how do you become the expert in that? And that's where chaos engineering comes in. So just to underscore this, chaos engineering is about learning. It's the process, it's not random. So if you've heard of Chaos Monkey or some of the other tools where they randomly destroy things, that's not a good way to learn, right? You don't learn by randomly doing things. You have to have a process. And so chaos engineering is about validating our mental models. How do we think things work? And if we think they work away, can we test to make sure that the way we think they work, that actually is true? And if it's not, how do we update our understanding? So we use this knowledge then as we understand our systems better, that helps us improve them. It helps us get faster at troubleshooting the problems. It helps us make better decisions when they have failures. And ultimately, as we do this, we build a practice. And this practice helps us become even better and gain more knowledge. And this practice then helps us to mentor others to help them gain more knowledge, and helps everybody get better. So how do we do this? How do we do chaos engineering? Well, the funny thing about trying to gain more knowledge is this is what we call science. Science, and the whole definition of science, is the pursuit of knowledge. So we follow the scientific process. And that's fairly simple. If you don't remember from your school days, the scientific process is about starting with a question, thinking about your system and asking a question, what would happen if? And then you have a hypothesis. This is, what do you think will happen? You write that down. And then you test that. You recreate the environment, or you, in the case of chaos engineering, you inject some failure and you see what happens. And then you analyze that. And then finally, you share it. Scientific method says that we should share our knowledge as broadly as possible so that others can help us and others can repeat it and validate that they see the same things. So if we do the scientific process and we start with, well, what's our question? A lot of people say the question is my application or is my system reliable? And again, I think that this is wrong. Again, we're focusing on learning. So the question is, does my application or does my system work the way that I think it does? Simply, do I understand things or is there a difference? And then your hypothesis is that I think that my system or application, given a condition, will react in a certain way. To test that, you simply then insert that failure, you replicate that condition, and you see whether the results actually match. So what did you learn? What can be improved? Well, if it matches what you think it should do, then that's fantastic. It means that you're a great engineer. Congrats. You've built things that work the way that you think they should. But oftentimes they won't. And that means either one of two things, either that you need to update the way you think about them, or maybe there's a problem in your application and your application needs to be updated to behave the way you think it should. But ultimately, again, you want to share this. So you share this with your engineering team. You share this with the entire engineering organization, right? Or you share it with the broader community like Spin Chennai or the broader SRE and DevOps communities. And so then you continue to repeat this process until your systems act exactly how you thought they would, or they behave the way you thought they would. And hopefully that means that they are then reliable. As you do this and you keep repeating, you want to start small. So we don't want to start with a big experiment. We want to start with the smallest experiment that we can that will give us some data. And then from there, as we repeat, we can grow it larger and larger to make sure that what works at the small scale will eventually work at the large scale. And one of the things about chaos engineering is, yes, you should do it in production, but you shouldn't start there. A lot of times people ask me, well, what if I'm afraid to do it in production? Well, of course, you would be afraid to write code directly and deploy it to production without running it through tests, without working on it in your local environment and then putting it through some testing. And the same thing happens with chaos engineering. You want to start locally in your own development environment. What happens if your application experiences a failure? Well, it's easy to test locally and to bring that in alignment with what you think. And then you can try it in staging, because staging should be somewhat similar to production, although it will never be exactly the same. So you try it in staging. Does this match the way that I think it should work? And if it does, once you're comfortable that your application or your system performs the way that you think it should, then you can move it to production. And by the time you're moving it to production, you should feel confident in the same way that when you're writing code and you're deploying that application, you've tested it enough. So you should feel confident that it's going to work in production. So don't overthink this. Don't overthink what happens in production, because you should work iteratively. Again, moving from development to staging to production. So by the time you're doing it in production, you'll be confident. But ultimately, you do need to do it in production. There's nothing like your production environment. There's nothing that will truly simulate your users except for your actual users. And so if you don't try it in production, there's no guarantee that any of your recovery mechanisms, any of your response processes will actually work. So you need to eventually do it in production, but build up, gain that confidence. So what does this actually look like? Well, let's do a little bit of a demonstration. And since we're all on Zoom, I might have some of you on mic, but I've got an application. I'll show you this in a bit. This is my application. I've got an online store. It's pretty basic. I've got things like a typewriter, so I can go and add that to my cart. It's got a place to check out. It's got some other products. So like many stores, it recommends that, well, you're buying a typewriter and you might want to plant. Okay, so I want to plant. I will add that to my cart as well. If I go back, well, we could see that I've got some different types of currency. So I'm doing dollars right now, but if I wanted to do euros or pounds, I could do those. Let's see what else we've got in here. Looks like our ad service is currently down. There's my ads. So I've got an advertisement here at the bottom. It says that vintage record player for 30% off. So I can click on that and add that to my cart. And then eventually, once I'm busy or done with all of my purchasing, I can check out. Pretty straightforward. The thing about this store, though, is it's actually based on a bunch of different microservices. So we can see the map here. We can see that sort of in the top middle, we've got the internet or the traffic, and we've got some simulated traffic from that load generator. They're coming down into the service in the middle there, which is my front end service. And then that's reaching out to a bunch of different services, such as my product catalog in the bottom middle, or the checkout service, which is just to the left of the front end service. So all of these work together. And so one of the things, as we have complex systems and your service becomes dependent on another service, and that service is dependent on a third service, outages can happen not because your code was bad, or maybe not even because the code you're dependent on is bad, but it could be further upstream. And so it could be a service 2 away or 3 away, or it could be a whole nother company, and that service goes down and it affects yours. So as we do this, we could have people maybe paste into chat if there's a service that you think is maybe non-critical. If this service goes down, the rest of the store should operate. If anybody wants to paste that into chat or unmute and comment on what you think is a non-critical service. Ad service. Great, yes. Recommendation, yeah. These are fantastic ones. Recommendation service is one that is common in a lot of systems. And for a lot of systems like Amazon or Netflix, if that recommendation service goes down, they simply have a static list that they show you. So rather than those, here's some more products that match what you used to be buying, why don't you consider those? They'll just show you the most popular products that are, that were from the last 24 hours, something that doesn't require any code. Yeah, email service. There's a lot of these on the back end. Emails, if I buy a product and I don't get my email receipt, within 15 minutes or an hour, that's probably okay, as long as I get it within a day. So these are all fantastic. So I'm gonna go to Gremlin here. As mentioned, Gremlin provides a service that makes chaos engineering easy and safe to do. Once I log into Gremlin, it's gonna provide some recommendations for me. So it's gonna say, think about your systems. Here are some common things that you might want to take a look at. One of the things that we just did is we added service discovery. So Gremlin has actually gone into my application and it's found all of these services for me. So since Sasi Kumar had mentioned ad service, that's right here on the top. It says you've got this ad service running. So I can click into that. And it has a bunch of information that it's already discovered for me about what this is, that it's running in Kubernetes, and here's the cluster that it's in, and some of the other information. And then if I wanted to add more, I could put a link to my dashboards or my runbooks. I can provide an owner here to say who owns the service. So if something goes wrong, I can contact that owner. Has a bit more information about the service and how many times it's been attacked, and it starts to track my reliability for this. So I'm going to say attack this service, and this is going to bring up my attack panel. It's already selected that ad service for me and the cluster that it's in. And so all I have to do is come down here into the Gremlin interface. So Gremlin has 11 different types of attacks. We can do resource attacks, so we can increase the amount of CPU or disk used, or disk IO, or memory. We can do a state attack, which is killing the process or shutting down this container or this server. Or in the case of servers, since I'm in Kubernetes now, this isn't available, but if I had a server, I could change the time on it, which is very useful for things like daylight savings time or summertime, which I know that I don't think India does summertime, but that's one of the challenges, right? Is when some people in the world change time and you don't, what happens when things are suddenly slightly different? And then we have network attacks. So network attacks, we have black hole, which drops all network traffic. And this is a great way to simulate that a service is down. We have DNS, so that blocks access to DNS servers, so you can't do name lookups. We have latency, which slows down that network traffic. And so it simulates poor conditions. This is a fantastic way to check for distributed systems, or if you have applications particularly that are doing things like having mobile clients, right? Your mobile phone is much slower and that network is much less reliable than any of your other internet connections. And then we also have packet loss. Again, great way to simulate mobile networks or poor network traffic. So for this one, because we're going to test for that ad service, we're going to do black hole. So what if that ad service goes down? And just to remind you, that ad service is here at the bottom of the product page. So I'm going to say black hole. I'm going to have it run for just, let's just do 30 seconds here. We'll keep this short. There's a bunch of other configurations that I can do with Gremlin. I'm not going to actually set these. The defaults will work perfectly fine for us. And I can unleash this Gremlin attack. The way that Gremlin works is we provide a service. So this is talking to the service, and then that's going to communicate out to agents that sit within the infrastructure. And so right now it's queued up this job. It says pending, and now it's running. It's actually communicated out to my Gremlin agents on that service. I also have a bit of monitoring here. So I'm using Datadog. I'll go ahead and make that a little bit bigger. It's showing me the past 15 minutes of metrics. I've got a pink bar here. Let's make that even bigger. That pink bar is really just showing me that I'm starting a Gremlin attack. So we've got an integration with Datadog. And we can start to track how that actually affects things. Instantly, though, we can see here with our traffic response time, everything was very, very fast. So barely shows up. And then suddenly we get this big spike on the ad service. So we know that our ad service is being attacked. It's having a delay because it cannot be reached. So if I come back to this page, well, let's just reload that and see what happens. Well, it reloaded very quickly. Looks like my ad service might still be there. I think I was talking for too long. Let's check my details. Yes. All right, let's rerun this attack. And I promise I won't talk nearly as long. Let's go ahead and reset this to be a bit longer. And we'll rerun that attack. So we'll wait for this to say that it's running, and then we can go back and check. But yes, it looks like this started and it basically ended. All right, so now we're running with our attack. We can come back, and if we reload, okay, we see that our advertisements is gone. Our site reloaded just fine. I'm clicking around. So it looks like I can still browse the site, and I can still add things to my cart, and I can still place an order. So in this case, for our experiment, we wondered what happens if we lose the ad service. And the hypothesis was that it was non-critical. So the site shouldn't be affected. And we validated that. So in this case, our engineers did a fantastic job writing the service and integrating it with the rest of our application. Now you can imagine with another service, if we run this, that maybe the results aren't so good. So I don't know how we're doing on time. I'm not actually going to run another one, although if we have time later, then perhaps we can.
Yeah, we do have another 30 minutes, Jason.
Okay, perfect. In that case, let's see. It looks like Raman said currency service. Yeah, that's another one, right? If the currency service goes down here and I can't buy it in euros or dollars, then maybe that Oops. Let's see. Let's make sure this attack that's still running. So I'm going to halt this attack in Gremlin, which is, again, one of those things that you want in a platform is if things go wrong, you want to be able to stop it. So I'm going to halt that attack. Yeah, so another thing, though, is that as we're talking about this currency service, if I change the service to another currency, if this service goes down, maybe it just defaults to buying in the default amount, which was probably dollars. And then it's up to my customers and their credit card to do the transaction or do the conversion. So similarly, again, we can go ahead and click on services and we can look for the currency service. So I will click on currency service and I can say attack this service. Again, I'll leave, it's already selected, so I'll leave the defaults there and I can say network. Actually, let's say rather than black hole, what if we make this just really, really slow? So we'll say latency attack. We'll keep that for 60 seconds. And what if we make it a full second slower? So 1000 milliseconds. Actually haven't run this before, so I'm not quite sure exactly what'll happen. So you're all learning with me. But I think, we've understood that our hypothesis here is if the currency service goes down, it defaults to a default currency and everything works okay. So we can see that it's running here. I can check in my monitoring. It looks like our currency service is here. Let's update this and see if we can see that our currency service is getting slow. We can see that that's ramping up in that dashboard. Cool. So let's go ahead and maybe click into that. We'll add it to the cart. Definitely feels like everything's running a little bit slower. So I keep browsing. Yeah, my cart is definitely slow. I clicked on that button and it is taking a long time to respond. What if I actually change to yen? Click on that product. Oh, I think we're fast again. So the attack is probably over. Looks like it's completed successfully there. So we definitely saw that it got slow. That implies that currency service might be more integrated with our system than we actually wanted. So let's try this again, actually. So we were in that attack page. Actually, let's go back to services here. Let's try this again. So we'll select our currency service. Let's say attack it. And let's try it with the original black hole attack. What if it just completely goes down? And let's go ahead and set this longer. So you can see again how easy Gremlin makes this. I don't have to worry anymore about logging into a system and actually changing my networking to test this, or I don't actually have to go into my cloud provider and kill this service because I don't want it to actually go down. I want it to stay up and just pretend or be isolated so we can pretend that it's down. And that way, if anything horrible goes wrong, we can stop it immediately. So it says it's running. If I go back into my cart, I clicked on that keep browsing button and it looks like my browser is just spinning. So no response. So we've definitely confirmed here that our currency service is not working and that it's taking down the entire site. So one of the things that we want to do as we're doing this is if this was actually in production, if we are affecting our end users, we'd want to come in here and just say to halt this attack. So we can confirm that. That'll immediately start that rollback. And so as that gets communicated out to the agents, that'll stop and the site will end up working, or it should work. It looks like we're halted there. It's been communicated out. So that's a quick, very simple demo, but I think you all get the idea of how to run a chaos engineering experiment. It's not that complicated. Again, it's just following that scientific method and that process. So before we wrap up, so a lot of people ask, how do I get started, right? We just ran these experiments, but is that a good way to start? So I really like to suggest 3 ways to get started. The first is to validate restarts. You are probably running your applications with some sort of system daemon that ensures that that process is running. Or maybe you're in containers and you use an orchestrator like Kubernetes, or maybe you're using virtual machines and you're using something like Amazon's auto-scaling groups. All of these systems are designed to notice when your application stops running and just restart that, right? That's the whole point of having a system daemon or a container orchestrator or a control group for your virtual machines. So that's an easy way to get started. Simply stop that, kill the process, kill the container, kill the VM, see if it comes back. And if it comes back, is traffic rerouted to it? Does it automatically connect to any data stores, whether that's a database or any file storage that you need? Does it come back and restart and everything work cleanly? I love this as a starting place because it oftentimes will uncover other issues. You'll notice that other things maybe get affected or don't work in the right way. And so it's a good, what I call trailhead. It's a good starting point for a lot of different experiments. But as things become more complex, you will generally start to find that restarts aren't quite as simple as you might have thought they were. The second way that I like to recommend that people start is to validate monitoring. And that's one reason that I had my monitoring tool here with Datadog, is the question, could we actually see this, right? Did we see that latency here? What was it like for my actual successful checkouts? So if I open this up and I look at the past, say, 15 minutes, did we lose the number of checkouts, all right? Did they go down? And it looks like in some cases they did. They definitely went down from where they were before. So you want to start to measure these things. And if you can't measure them, it's much better to find that in a chaos engineering experiment than in an actual outage, right? You never want your actual outage to happen and not to be able to see that. So validate your monitoring using chaos engineering. And the last way that I like to use it is to replay incidents. Think about the last incident that you had, the last failure, the last outage. And think about how stressful that was. As you were trying to solve this, the things that you were trying to figure out, what didn't you know? What didn't you have access to? Where was that documentation? Usually what happens is after that incident, you spend some time, you do a retrospective or a postmortem. You ask yourself, how can we improve this, right? So you write up some tasks of, well, we should fix the application here, or we should improve the documentation there. But you never know whether those actually would have fixed the incident until you replay that incident. And you don't want to wait for that incident to happen again. So use chaos engineering and try to replicate it and then test it out. Does my fix actually work if those same conditions occur? Or if I have to respond to that same thing, can I follow the process that we now have or that documentation we now have? And does that work? Those are 3 fantastic ways to get started. They're how I generally advise all of our customers to get started. But what's next? Well, we've done dependencies testing. You kind of saw how that worked. We black hole one of our services. We see what happens, how that affects our other services. The other great way to use this, though, is to start to test your failover. Right? If you're thinking about, I'm in the cloud now, I have different availability zones, I'm in different regions, or maybe I'm even multi-cloud. I'm using 2 major cloud providers in case one completely goes down. Well, failover is never as smooth or automated as we think it should be. And so a great way to get better at this and to ensure that this failover is fast is to actually test it and practice it and get better at it. And then finally is to work on automating all of this. We all hopefully are writing tests for our code, and we're writing tests for everything that we're deploying. Chaos engineering, as you do it more and more, as you build it into a practice, eventually, if we're testing for that ad service and that the ad service, when it goes down, it just comes back, or that the ad service doesn't impact the entire store, we can now automate that. So one of the nice things with Gremlin is that when we're in here and we go to run a test, we can actually just click on this Gremlin APIs example rather than clicking on the button to unleash it on the left. If we click on that Gremlin API examples on the right, it actually provides to me all of the information about how to run this against our API. And so I can take this information and run it on the API and then start to easily automate what I'm doing. Some of the benefits though, a lot of people are like, this sounds great, it sounds fun, or it sounds interesting, but does it really work? We ran a study earlier this year. We interviewed 400 different organizations about chaos engineering and how they were doing it and what they saw. And we saw the results here. It might be a little bit small, but 47% of these organizations that started doing chaos engineering saw increased availability in their applications. 45% saw a reduced mean time to resolution, so they were solving incidents faster. 41% saw a reduced mean time to detection, so they detected the incidents, they improved their monitoring. 38% reduced the number of bugs that were shipped into production. 37% saw a reduction in the number of outages. 25% saw a reduction in the number of pages. So they just never received those pages because things were working good. Overall, we found that teams that frequently run chaos engineering experiments have 99.9% availability or higher. And 23% of teams that were practicing chaos engineering regularly were able to solve incidents in under an hour, with 60% of them able to solve incidents within 12 hours on average. So lots of benefits of running this, because again, as you focus on improving your knowledge and getting this, using this practice, improve your experience as an engineer, you're going to get better. You're going to build better applications. You're going to respond faster and respond better and make better decisions when you have incidents. So that said, I can open it up to questions. Also, I forgot to post the link to the study here, so I will go ahead and pop that into the chat. I spelled that right. I think I did. That should be the link to the report for you.
Fantastic, Jason. See, one of the quick question is, suppose I, as a client, come to you for chaos engineering platform. So you do the testing, and what is the kind of report you will give me? How does the report look like?
Yeah, sure. So you do the testing on your own, right? The platform is here for you to use. We do have some reporting available. The reporting primarily for our customers is around who's running attacks and how many attacks they're running. So if this is my example group, we can see that I've got a number of teams. So that's one of the things that Gremlin provides, is the ability for you to have as many teams as you want within your organization. And we can see how many attacks they've run, how many clients they have available, how many total targeted attacks, things like that. So there's a bunch of reporting on usage. One of the things as we start to build out services here is you'll start to get some reports here as well on this service of how many attacks and how many have been this month. And then within each of these attacks, we can start to actually record notes and observations. So that'll help tie the information back to this attack. So we're starting to build even more reporting. The services auto discovery that we have here is the first step. But ultimately, what we want to do is take this, so you see your services, and we can start to do some more monitoring of them, right? So we can start to say, not only have you attacked the service, but you could start to record that reliability and get a better sense of it. So that's not quite fully there yet. We're making progress toward that. Service discovery, again, was the first major step towards that. But eventually, yeah, as we build this out into a reliability platform, that'll be there. And you'll start to get more intelligent suggestions as well on what you should look at and where your reliability might need some further investigation.
So it is more of a self-service platform rather than
That's correct.
You delivering it as a consultancy or a service, customized service.
That's correct. Yeah, the idea here is that as we think of chaos engineering, and again, as I've started thinking of this as how do you make engineers better and more knowledgeable, you really want to democratize this ability, right? You don't want, if I run the chaos engineering for you, well, then what are you actually learning? So it's better for you to run it and you to get hands-on and you to see it and for you to control everything. And that way you learn the most. And by learning that, then you're able to build better applications. That said, I should say we do have professional services available. So if you are a Gremlin customer and you need some help, we have engineers that will join your team and help you run experiments and help you integrate Gremlin into your applications as well.
Okay. So this platform, how is it costed? Is it a free one or is it something you charge?
Yeah.
How do you monetize it?
Yeah, so we have a number of different pricing tiers. We do have a free tier. So if you go to gremlin.com/pricing, you'll notice our pricing here. We do have a free model. It allows you to install 2 agents and have 1 team. And then you get to attack 2 targets per month. So it's a good way to try things out. We have a starter tier as well. That's for small teams that are just starting out. And then we have different levels. We have a pro level and an enterprise level. And so those are really come down to what your needs are. If you're interested, definitely check this out and you can request a demo and that our team will actually show you what this might look like for your organization. Or feel free to reach out to me. I'm always happy to chat and connect you up with somebody who can talk to you more about your needs and what that pricing might look like.
Yeah, can you also share one example of a client who walked away with a huge win out of this, after this platform?
Yeah, I can think of several. So one of them that's been really successful actually did a test exactly like we demoed today was Mailchimp. So Mailchimp, for those who aren't familiar, Mailchimp is a company that provides a platform that sends email. And so if you are anywhere from a large business and you have a mailing list and a mailing email campaign, and you want to send emails all the way down to, your small local stores that have, a mailing list, or maybe, like a lot of rock stars and musicians use it for their fan lists. It allows them to send emails. And so they send, I think they said that they send something like 5 billion emails every single day. And so as their platform, you log in and you're able to create custom emails and make them look nice. And so they do a lot of these microservices to provide little features for that platform. So one of their features that they were testing out, they were doing exactly what we're doing, trying to test what's non-critical. And they'd rolled out this feature and they're like, well, this is our new feature. It shouldn't be critical. If that goes down, nobody should notice because it's just a nice add-on. So they ran a black hole attack like we did here. And and it took down the entire service. So everything went down, and thankfully it was just a test. They immediately noticed it, and they were able to click that halt button. And so customers on the front end who might have experienced it, they just reloaded and everything was back to normal. So that's one great use case that we've seen. Some of the other use cases, I was just doing a bunch of chaos experiments with JPMC or JP Morgan Chase, the bank. They ran a bunch of them. They used, for one of them, they used the process killer. So they shut down one of their processes, and they were doing it as one member of the team would run the attack and everybody else wouldn't know what that attack was. And so they would respond as if it were an incident. So they killed the process. The team used their monitoring tools, instantly saw that it was the process. But the interesting thing was in their response, the response was simply, well, let's run the script and restart the process. Turns out that they discovered that some of the team members didn't have security permissions to run that script. So had this been in an actual incident and one of those team members was on call and responding, they wouldn't have been able to fix it. So by running this game day and doing it as chaos engineering experiment, they were able to discover, hey, not all of our team has the right permissions. They were able to quickly fix that. And now should anything happen in the future, everybody is equipped to actually respond. So those are two of the stories that I like to share. That the JPMC one was one that we actually just ran, I think 2 weeks ago. So.
Yeah, Jason, chaos by its name indicates that there are multiple attacks coming at the same time or some unpredictability. Whereas the experiments you showed so far seem to convey some predictability element and one level of attack.
Yes.
So any comments on that?
Yeah, chaos engineering is, it's poor marketing, I want to say. So chaos engineering, actually, the name of it came from my friend Bruce Wong when he was at Netflix. It primarily came because they had the tool Chaos Monkey, which again was, Chaos Monkey was more random. Chaos Monkey would randomly destroy servers. But as they started to build up this practice, chaos engineering, they realized the randomness is not useful until you reach a certain point. As I mentioned, eventually you build this practice and you're doing it enough that you always expect the same results. And when that happens, just like anything in engineering, you want to automate it. And so once you automate it, then yes, then you can do it randomly and hopefully you should never notice. But as you're starting out and as you're getting into this, you do not want it to be random. You want to be very methodical about it. You want to have a process so that you can learn as much as you can.
Okay. Yeah, we have several questions that have come from the audience participants. Maybe Kumar Venkatesan, he has a couple of questions. You can go one after another, Kumar.
Yeah, thanks, Jason. That was an enlightening, insightful presentation and a demo. It started with interesting stats on the failures from AWS, GCP, and Azure. So my first question is, are there any shortcomings of the current fault tolerance disaster recovery, which has been in practice for a while? So I am not sure, is it a convergence of DevOps and disaster recovery and all these things? Because I'm a novice in this field, so I just want to hear from you. This is my first question, Jason.
Yeah, I'm not sure that I quite understand the question. Can you repeat it?
No, currently we have disaster recovery management, BCP, and fault tolerance mechanisms, one way or the other. So, how important is for the chaos engineering? Is it a amalgamation of all these things, or superset of all these, or is it something like a specialized engineering mechanism? So that is my that's a clarity I want. Thanks.
Yeah. So I think the real difference here is that as we've moved to the cloud, as we've started to have more complex applications and infrastructure, there's been a need to become more proactive. So a lot of times your BCP or your disaster recovery has been this planning of what happens if, and sort of building out a plan for that disaster, but never actually doing it, right? It's a lot of thought experiments of what would we do if this was the case? Well, let's write that plan. Let's maybe test a little bit, but let's write it out. And the problem is that with complex systems, failures never happen the way you think they will, right? A lot of the study that's been done in the resilience engineering space has come down to the fact that you often, when things fail, it's a collusion of events. It's never just one thing. There's no single root cause. And so because it's always like a mixture of things of, a service in AWS happened to be down, but at the same time, we happen to get a spike of traffic that happens to overload our load balancer, and then it couldn't do something. Things like that are very hard to plan for. So the only way to really prepare for that is to get proactive and to actually start to introduce failures in ways that you could hopefully expose these things. Because you can only write a disaster recovery plan if you know about the disaster, or you know what the disaster is going to look like. And the problem is that nobody can anymore. You don't know what those disasters look like. You don't know how they'll play out. And so you can't really write that comprehensive plan anymore. Does that make sense?
Yes, yeah, perfectly. Thanks a lot, Jason, for the clarity.
Yeah.
And the second question I asked, but I got your answer, was, so do you have any command line interface for these, demo which you had shown on Gremlin?
Yeah.
I think you had showed that API link was opening. So I got that answer. So that is mine. Thanks.
Okay.
Yeah,
Great.
that's all. Thanks.
Yeah, we have a question from Sri Krishna Parthasarathi. Okay, you can unmute and ask your question.
Yeah. Hi, Jason. Good evening.
Hi.
So kind of see this SRE and chaos engineering, right? Like I assume chaos engineering would be a subset of SRE kind of discipline, if I'm not mistaken, right? Like, but SRE is a broader kind of an umbrella. Can you clarify those aspects?
Yeah. So if we think about SRE and practices, this is one of the practices that's important for SRE. I like to think of it in the same way that monitoring is an important skill for an SRE to have. Chaos engineering is as well, because one of the SRE tenets is embracing failure. And so as you think about embracing failure, obviously the way to do that is to cause your own failures, right? Cause your own failures and learn from them. So it's definitely an important skill for SREs to have.
The other question is about Gremlin. Do you have like an open source community, or it's by itself? And I know there is a free version in the website, right, for the product. Is there an open source community around this chaos engineering?
Yeah, so we aren't open source. We do not have any open source software. The agent isn't open source. It is, you receive the compiled binary. And some of that has to do with just security around it. There are, if you are strictly needing open source, there are some tools that are available. They're usually highly dependent on what sort of system or application you're running. For example, if you're running in Kubernetes, there's a thing called Litmus Chaos. So there's some other tools. If you do need open source, feel free to email me. I'm happy to share some of those tools with you. But Gremlin itself is not open source.
Sure, thank you. Yeah, thank you.
Shashi, you can unmute and ask your questions, please.
Yeah. Hi, Jason. This is Sashi here. Thank you for the session. This was my first introduction to chaos engineering and yeah, I could understand that. One question that couple of questions that I have. The first one was like the attacks, the kind of attacks that you shared, like you said, Gremlin has 11 types of attacks and some services that we can do to simulate this chaos engineering. My question is, are there any extension points that if someone wants to extend these attack types or some other things, are there any extension points? Number one. If so, how do we go about it and what are the best practices?
Yeah, that's a great question. There's no extension points in terms of creating custom attacks within Gremlin. We do have ways that you can integrate with Gremlin. So let's see, if I go back into Gremlin here, there's a couple ways that we can do that. One is with webhooks. So if I go into my settings here for my team, I have the ability to set up webhooks, and we can see, it looks like somebody has already set up some. So it looks like I've got a webhook visualizer here that someone has set. So you can use webhooks to integrate with Gremlin in terms of, a lot of times this will be for getting this into your monitoring tool. For example, send a webhook whenever an attack is run or whenever attack is completed. Although some organizations will use this whenever attack is run, they can also kick off or start some additional attacks of their own. The other way that you can sort of do this integration is with what we call status checks. So we have, I was just running one attack, but we actually have the idea of a scenario, and a scenario is a group of attacks or multiple sequential attacks. As part of that, though, we do have a status check step as well. And that status check, essentially, if we look at this one, I'll go ahead and edit that. So this particular scenario, what it's going to do is it's going to run a status check, and that's going to allow us to provide some information and then hit a URL endpoint. And that could be a monitoring tool like Datadog, New Relic, PagerDuty, or it could be custom. So anything that you want. And we could provide it some header information. And then we can actually check the response body for that endpoint. So again, normally this is used for monitoring. And the idea here is that prior to running an attack and throughout an attack, if I want to check to ensure that my system is still reliable or still available, I can constantly check on my monitoring. And should my system actually stop becoming available, then I can immediately stop that attack. So that's what the status check does. There are ways that you can, again, sort of use this in other unintended ways, to example, launch new attacks that might be custom within your own application, or to integrate with other systems. So those are sort of the extension points. We are working on additional extension points. We've just started that, particularly around monitoring for some of our customers, but eventually we'll be working on integrations with the major cloud providers like Amazon and Azure to do some of the attacks on their managed services.
Okay, thank you. My second question is, do we have tools to integrate with monitoring services? Like, does Gremlin connect with the monitoring service to say that, suppose on a live system, if there was an attack, and how that attack is being handled by the current application or the services, and to see, and is there a way that we can prevent that kind of thing? So does it have any connectivity to monitoring service?
Yeah, so again, I think that's where this status checks would be, right? So for this particular status check in my scenario, what it's doing is it's going to go out and ensure that it's going to check the status page. And again, I can set that for any of my monitoring tools. But what I can tell it to do is check this monitoring tool verify that you're receiving a good signal and that things are operating correctly, and then continue the attack if it is, or if it's not, to immediately stop that attack.
Yeah, and thank you. That's all I have.
Okay. Any other questions? Let's see.
We seem to have a question from Mr. Gopal. He has raised his hand.
Thank you so much. It was a very nice and lucid presentation. By and large, systems people make things happen faster when the system is flayed. We welcome people to break into the system in as many ways as possible. So that being the case, what I find is Gremlin was nice idea to make us shake off that dependency on too much of determinism. We are really very conservative in creating our systems, particularly when we are talking about scalability in terms of users. We tend to block many things. That's how our systems are designed in India. We don't allow remote login. We don't allow very many things to just get connected. Bring your own device is a good idea. No doubt about it. A lot of things have been simplified and people thrived on that model, but our systems are like that. We don't spend much on security stacks. So we tend to block. How much can we relax is a question. Instead of simply moving around on simulations, Gremlin, the free model, was giving us good pointers as to how much relaxation can happen. It's a good idea. Thank you so much. But what else can happen? Relaxing on the deterministic model is fine, but can I see the border of chaos? How do I see the border of chaos and work backwards? From what is comfort zone as deterministic, I'm okay on relaxing, but I want to anticipate the border of chaos and work backwards. That is something which I thought I need to cross-check with you.
Yeah, that's an interesting question. If I understand it, you're asking if essentially can you use chaos engineering to find the edge of where your systems break and use that?
Yes,
yeah,
exactly the concern. Can I anticipate at least a yield point or a break point? Break point is further, yield point.
Yeah. That's so generally we have people work the other way, right? Of slowly increasing until the breakpoint rather than finding the breakpoint and working backwards. I think you could do either, to be honest. I think generally because people are more conservative and they don't want to break things, if you start small and you build up and you work until you break, then it means you only break once. If you start with the extreme and you break and then you dial it back to less extreme and you still break, and then you dial it back to less extreme, you still break, and then eventually you work down to the point where you don't break, that means you're breaking a lot. So I think that's the only reason that we really recommend starting small and building up. That said, either way works, right? I think the idea is for both is trying to figure out where that point is and really validate that, okay, that's my threshold, doesn't meet my understanding, and what can I do to then keep pushing that threshold out to make it more reliable?
That's right. It's difficult to talk to teams when we are touching the yield point and break point. It's a lot more easier, as you rightly said, work within the deterministic framework and see how to extend it in small steps.
Yes.
Makes sense, but yeah.
Yeah, I think continuing on Professor Gopal's question, so is there a cost factor involved while determining, the extent of testing you would like to do, the breaking testing?
Yeah, I mean, so there's not really a cost factor for Gremlin. You pay for the plan that you're on and you get the resources that you need. There can definitely be a cost factor in terms of the systems that you're running, right? If I'm running in Amazon service and I'm trying to build a reliable system, it might mean that now rather than just the servers that I need to buy more servers or have more resources so that it can fail over and have redundancy, or that I can have a whole nother availability zone. So there's definitely some cost involved there. And it must be weighed with, how much is it going to cost you versus should something bad happen, should you have an outage, how much will that cost you and how long will that take for you to recover?
And in terms of time, what is the minimum time you look at for doing these experiments?
Yeah, that's highly variable depending on what you're running, like what sort of experiment you're doing, what your application looks like. In terms of, so that's for the experiment itself. In terms of time, as far as like how much time should engineers spend to do this, we found that companies that do it regularly, at least quarterly, usually have the best results. And so, for example, I mentioned that I was working with JP Morgan Chase, the bank. They run it with a team. They dedicate one day. So they'll have a day and they make it a fun thing. They'll order food and just like everybody has this one day and they'll do usually like 6 or 7 experiments for that day. And so basically it's, someone runs the attack and the team responds, and so they do that. And it's usually half an hour, 45 minutes, or some of the longer ones are about an hour. And then they'll take a break, and everyone can go to, get some food or something. And then they'll come back and they'll run another one. And so it's one day where they get together and they have a lot of fun with it. And they get to, play around. Other teams, it's been smaller. At Gremlin, we started doing just half an hour. So basically every 2 weeks, 3 members of a team will get together for half an hour and they'll run a very short experiment. And so for us, it's been much smaller, and that way it's less impact on the engineer's time and they can still focus on getting work done.
Are you planning any certification around this?
Yeah, so we're in the planning stages. We've rolled out the certification to a couple customers of ours just to get feedback, and we're currently receiving their feedback and trying to incorporate that. But we plan to have the certification released publicly later this year.
Okay, fantastic. I think that this will be the last question. See, cyber security becoming a big theme. So how is that overlapping the top 10 of OWASP or 25? How do you merge it with these experiments?
Yeah, there's definitely some similarities between chaos engineering and a lot of what penetration testers, pen testers do in the security world of how can we stress systems for them? How can we stress them so that we might be able to find, a crack or a weakness that we can exploit? We've generally stayed away from that, primarily because if you're working on reliable systems, you'll be less prone to those security attacks. But those security attacks often take advantage of things that are much more obscure, much more ingrained in various softwares. And so it's hard for us to build a platform that's broadly suitable to be able to test those. So we've generally stayed away from the security. But as you're doing chaos engineering, if you do have a security team within your organization, it's highly recommended that you work with them as you're doing these chaos experiments.
Oh, fantastic, Jason. I think we are right on time. Exactly 90 minutes, you completed. If there are no other questions from the audience, then we will call it a day. I know it is slightly late for you in the night. Thank you very much for a very enlightening session. Definitely, this is a very important topic and exercise for all of us, because of India being one of the software capitals. I am sure this as a topic is highly important for our teams. So we will continue to engage with you, and we will also encourage more people to visit your website and also access this video on our channel. Thank you, for your time, and thank you all the participants for your engaging and interesting questions. And hopefully, we will very soon meet in another interesting session in May. Thank you very much.
Thank you.
Thank you all.
Let's give him a big hand. Yeah. Thank you, Jason.
Good night, Jason. Thank you, Hajara.
Yep. Have a great day.
Yeah, thank you.